Hello and welcome to today's lesson on density. Our plan for today's lesson is as follows. We will first explore density as being how tightly packed the particles are in a substance. This will provide the foundation for calculating density. Finally, we will apply this understanding to explain why some objects sink and others float. Let's get started. Density can be thought of as the crowdedness of a place. It gives us an idea of how tightly packed the particles are within a substance. To visualize this, imagine two scenarios, one where you have 100 people in a small room and another where you have 100 people in a large park. The small room would feel very crowded because the people are tightly packed together, indicating a high density of people. On the other hand, the large park would feel spacious because the people are spread out, indicating a low density of people. Similarly, in physics, substances with tightly packed particles have high densities, while those with particles that are more spread out have low densities. To understand density quantitatively, we need to consider two physical properties, mass and volume. Mass refers to how much stuff or material is present in a substance. Using our earlier example of crowds, mass is equivalent to the number of people we have. In contrast, volume refers to the amount of space that substance occupies. The formula to calculate density is density equals mass divided by volume. Here, ρ represents the density, m is the mass, and v is the volume. With this equation, we can see density measures how much mass is packed into a given volume. Let's now pay close attention to the details of this equation. Mass represents the amount of matter within an object. Mass is typically measured in kilograms. It's a scalar quantity, meaning it only has magnitude and no direction. Volume represents the amount of space an object occupies and is usually measured in cubic meters. It's also a scalar quantity. Volume can be calculated for different shapes using specific formulas, but its unit remains cubic meters in SI. The standard unit for density is kilograms per cubic meter. This unit indicates how many kilograms of matter are packed within a cubic meter of space. Density also plays a crucial role in buoyancy, which is the ability of an object to float in a fluid, like water. An object will float if its density is less than the density of the fluid it is placed in. Conversely, an object will sink if its density is greater than the density of the fluid. For example, a heavy rock sinks in water because its density is greater than that of water. On the other hand, a light, fluffy ball floats because its density is less than that of water. Let's now apply what we've learnt to some practice problems. We have a metal cube with a side length of 0.5 meters and a mass of 50 kilograms. We need to find its density. First, we identify the given quantities. The side length of the cube is 0.5 meters, while the mass is 50 kilograms. To calculate the volume of the cube, we use the formula volume equals the side length cubed, which would give us 0.5 cubed. That equals 0.125 cubic meters. Next, we use the density formula. Density equals mass divided by volume. When we plug in the values, we get density equals 50 kilograms divided by 0.125 cubic meters. When we calculate the result, we get the answer that the density of the cube equals 400 kilograms per cubic meter. Let's try a different practice problem. A wooden block has a volume of 0.02 cubic meters, and its density is 600 kilograms per cubic meter. We need to find its mass. Like always, we identify what's given. The volume of the block is 0.02 cubic meters, and its density is 600 kilograms per cubic meter. Since we need to find the mass, we rearrange the density formula to mass equals density multiplied by volume. When we plug in the values, we get the equation mass equals 600 kilograms per cubic meter multiplied by 0.02 cubic meters, which gives us 12 kilograms. Therefore, the mass of the wooden block is 12 kilograms. For our last question, we have two liquids. Liquid A has a mass of 350 grams and a volume of 0.5 cubic decimeters. Liquid B has a mass of 0.4 kilograms and a volume of 600 cubic centimeters. We need to compare their densities and determine which one is denser. In a question like this, always check if the units need to be converted. In this case, for liquid A, its mass of 350 grams is equivalent to 0.35 kilograms. The volume can also be converted from 0.5 cubic decimeters to 0.0005 cubic meters, since 1 cubic decimeter equals 0.001 cubic meter. For liquid B, its mass stays as 0.4 kilograms, but we need to convert its volume from 600 cubic centimeters to 0.0006 cubic meters, as 1 cubic decimeter equals 0.000001 cubic meter. Then we calculate the densities. Using the formula density equals mass divided by volume, we can calculate that the density of liquid A is 0.35 kilograms, divided by 0.0005 cubic meters, which equals 700 kilograms per cubic meter. We then repeat this calculation for liquid B. When we plug in the values, we can work out that the density of liquid B equals 0.4 kilograms, divided by 0.0006 cubic meters, which equals 666.67 kilograms per cubic meter. To answer the question, we then compare the densities. The density of liquid A is 700 kilograms per cubic meter, whereas the density of liquid B is 666.67 kilograms per cubic meter, meaning liquid A is denser than liquid B. Great work today. Here's a brief summary of what we covered. We discovered that density measures how tightly packed particles are in a substance, with high density indicating more packed particles and low density indicating more spread out particles. We then learned the formula for density, which is density equals mass divided by volume. This helps us determine how much mass is contained in a given volume of a substance. We also explored how density affects buoyancy, learning that an object will float if its density is less than the fluid it is in, and sink if its density is greater. Finally, we practiced solving problems related to density and buoyancy, applying these concepts to real-world scenarios. Next, we'll delve deeper into how density relates to the 3 states of matter. See you in the next lesson.